Hello and welcome to the MaML podcast. I'm your host, David J. H. Wu, and today's episode features the team behind CardinalKit, now known as Spezi, an open source framework for digital health applications and research. Spezi is housed in the Stanford Bayer Center for Biodesign and is directed by Dr. Oliver Alami, with Dr. Vishnu Ravi as lead architect. Also joining us on this interview is postdoc Paul Schmiedmeyer. I had a blast talking to this awesome team and learning more about the cool tools they're building to help anyone create new digital health apps from the ground up. I really felt the chemistry between them as builders, as well as how their different skills synergize together to create Spezi. If you're thinking about building something in the digital health space, this episode is for you. And as always, don't forget to follow us on Twitter at the MaML Podcast and join our Discord community for more. So Vishnu, Oliver, and Paul, it's so great to have you on the show today. Our first question that we ask all guests is, can you tell us briefly about your paths and how you came to the intersection of medicine and machine learning?
Absolutely. First of all, thank you for inviting us. We're excited to be a part of this. So, my name's Oliver Alami, and I'm a vascular surgeon, actually. So I think it's a little odd. Yeah, not a typical pathway. But, have been working on digital health applications for about 10 years, just studying the sensors that are coming off smartphones, smartwatches, and patients with cardiovascular disease. And, just building CardinalKit and now Spezi over the years, it became clear with the latest advances that there's great potential with machine learning and AI, not only with these new generative AI models, but even before that, whether it's imaging and so on. So just super excited and interested. And the line I always give is, how do we optimize or maximize the potential for all this technology? Because as we'll get into later, sometimes the technology is not the hard part. It's the implementation, translation, that's the hard part. So yeah, get into that later. I'll stop there.
Great.
Yeah, I can go next. My name is Paul Schmiedmeyer. I did a PhD in computer science back in Munich, Germany. And so my background is really from the computer science domain, which is kind of nice in our team. We have really the full width of medical expertise and computer science expertise right here on the podcast and in our team. And I'm approaching this from an angle of how to apply the fundamental ideas that are existing in computer science, sometimes for decades, and how to apply this to the digital health and medicine domain. And I did some seminars back in Munich, which were about applied machine learning. So really the question, is it actually worth doing machine learning for some problems? Is it maybe expert system? Is it maybe better to do an old-fashioned algorithm in that case? Or if you're looking at machine learning, what's the best mechanism? What's the best use for these technologies? And especially also looking in the digital health domain. And I had joined Stanford as a postdoctoral researcher here, and now since about a year actually, we've been really working on the CardinalKit ecosystem and transformed it into what we now call Spezi, which is our new modularized architecture, which, for example, also includes models for machine learning and really trying to help in that intersection, especially around mobile applications and connections to the EHR system. And Vishnu is really our expert in that space. So you can go next.
Thank you, Paul and Oliver. Thank you again, David, for having me on the podcast. This is awesome. I guess my story kind of begins when I was a kid. I was always passionate about coding. I started coding when I was about 7 or 8 years old.
Wow.
My mother's a physician, so some of my earliest work was in the healthcare space. I got to work on some projects with her, and that's where I kind of saw the potential in at the intersection of computer science and medicine. Because back then, most of the systems were very, very basic, very rudimentary, just basically copying, a physical chart, but into the computer, for example. And we hadn't really heard about things like machine learning and AI and trying to make predictions based on data and things like that. So I was really excited about the potential. And so kind of went into medical school with that lens of trying to figure out how I can apply my computer science programming skills to medicine. And one of the earliest projects I worked on as a medical student was creating a conversational agent for an electronic health record system. And at the time, this was, 2013.
Wow.
very much in its infancy. So I was one of the first people to do this. Alexa had just come out. It wasn't that good, but it worked. Got it out there and learned a lot in the process. Also developed an algorithm for basically prioritizing clinical documents and extracting entities from unstructured health data, because you see that there's a lot of unstructured health data out there locked up in notes and reports and things like that. So there was a big need for creating algorithms that can actually like read that data and structure that information. So I did a lot of that kind of work in medical school as well. After medical school, went to residency, did residency in internal medicine, and following that started practicing internal medicine, and very shortly after came upon Oliver's team working on CardinalKit, and I thought this is amazing because I'd spent my whole life building digital health applications. Now it's been 10 years since I built my first one as a medical student, and every single time, you have to start from scratch. You have to assemble things together, and there's just a lot of boilerplate that goes into it. And when I saw CardinalKit, I thought this is amazing because we can start with this kind of like pre-configured architecture and build on top of it rather than trying to reinvent the wheel every time you want to make an app. So I got really excited by that, joined the team, and I've been working for the past 2-3 years. And we'll tell you more about CardinalKit, which is now Spezi, and everything that went on behind it. But really excited about the fact that we've been able to expand it now to 20 plus projects that we actually are working on ourselves with different researchers.
Wow.
And a lot of other institutions around the country. Actually, Paul was in Germany. He found us online through our GitHub, contributed, and we ended up bringing him to the US. So he's American now.
It's like you poached him.
We poached him. But then since then, we've recently been back to Germany, and we've made some connections with some institutes over there. We're really excited about using CardinalKit and Spezi. So it's been a whirlwind over the past 2 to 3 years, and I'm really excited about where we're going next, especially with the machine learning work that Paul and Oliver were talking about.
I think Vishnu, when it comes to data science and healthcare, you talked a lot about unstructured data. You need to talk a little more because you have such a high skill level, I think.
Yes.
And also passion around data standards, interoperability, and how important that is when you're doing this kind of work. You need to talk a little bit about the experience you had either with OpenM Health and beyond. I mean, I think you're very skilled in that arena. Do you want to talk about that a little bit?
Yeah, I think Oliver, that's kind of
work, and that's important. I think standards and that was we baked that expertise into the framework.
Exactly. I think
you need to talk about that.
Absolutely, that's a really good point. I think one of the issues historically in healthcare technology is that there has been a lack of interoperability and data standard, and so you have lots of different systems that are storing and representing data in different ways, and that makes data analysis and machine learning and all these sorts of things more difficult. And recently, we've seen many standards gaining traction. For example, HL7 FHIR is a standard that you may have heard about.
I have not. Well, what is that?
Oh, great. Okay, well, that's
Okay, very important.
HL7
for our listeners too.
It's going to be the rest of the podcast. HL7 is a standards body, an international standards body that's responsible for creating a lot of different standards that have been adopted in the healthcare industry. And the latest standard that they've developed is called FHIR, for FHIR. It stands for Fast Healthcare Interoperability Resources. And the kind of motivation behind that was to create a standard that could be used for different healthcare systems to exchange information in a modern manner, similar to other systems on the web, like any kind of website or web server or any other kind of system you would build an application to send or receive data from as a developer. You normally use what's called a REST API, and the data is usually sent in a format called JSON. And these were not common in the healthcare space and healthcare software. And so HL7 FHIR kind of brought these modern technologies to healthcare to make it easier for these systems to communicate, make it easier for third parties who are developing applications that want to work with electronic health record systems or insurance APIs or anything like that, to be able to connect and to be able to share, exchange data, basically, because the data is represented in this kind of universal format, so to speak. I mean, it's not perfect, but the idea is that there is a a universal kind of format that can be used to exchange data. And then when we developed our system, specifically Spezi, what we did is we baked standards specifically into the core of it. And the idea is that, and Paul can tell you more about that, because this is something that Paul did a lot of work on structuring this whole concept. That the idea at a high level is that Spezi is made up of a number of different modules that each have its own functionality. Like there are modules for sourcing data from devices. There are modules for creating user interfaces for like displaying surveys for patients to be able to fill in information. There are modules for being able to export data to a cloud database or another type of data storage provider, or store it locally, or send it to a machine learning model for some sort of analysis or prediction, right? So we have built modules for all of these things, and the modules are taking in data in different formats. They maybe have to put data out in a different format, but internally, they all use a standard, and that allows us to kind of make modules that are interchangeable, which is actually really, really important, because we don't want to build those kind of monolithic applications, really. Like, so the original CardinalKit was in some way a monolithic application, and if you wanted to make changes and you wanted to expand it, it wasn't quite as easy. But now, because we have this modular architecture, you can kind of plug and play different components on top of the structure. You can swap out different components, and because of at the core of it, there's a central shared repository that speaks the same language, the data standard. All these modules can interoperate, and the standard could be anything. So we don't force you to use HL7 FHIR. You can use another standard that I've been working on for some time called OpenMHealth, which is a great standard for representing mobile health data that comes from wearables and mobile devices. It's really good for that. So you can use a standard like that. You can adapt your own standard to this setup. But what we provide out of the box is support for HL7 FHIR. And that's really important, because all of these EHR systems on the market, like Epic, like Cerner, Athena Health, Allscripts, you name it, they all have support for HL7 FHIR. And there's even legislation that mandates that any healthcare system or provider that has data available in an electronic format has to make that data available to patients by means of an API. And the format that those APIs take is FHIR. So that makes it really easy for you to build digital health applications using Spezi that can interoperate with all these other systems out there, consume data, and send data back. And that's a really big thing that's been missing in healthcare for a long time. Sorry, I spoke a lot.
That's great.
Yeah. That's an area that I'm very passionate about. So
No, yes, and I can't highlight enough how these literally the legislation that Vishu is talking about, the requirement to expose a FHIR API literally was December of last year where that passed.
Oh my goodness.
Yes, in December of this year, you need to expand, or there's a requirement to expand the data elements that are exposed. Initially, it was like 18 elements or something, but it's supposed to be almost all the, all records are supposed to be exposed. So in a way, there are these huge tailwinds, and we're on kind of this precipice of like major opportunity for innovators such as yourself, to build on top of EHRs and bring value to the consumer, the patient, or other third parties.
Yeah, I feel like I'm almost talking to like an Avengers team of you each bring such unique your own skill set, and you're building this awesome thing that anyone can use. It kind of feels like the Avengers of the healthcare and digital health space are being made in my head right now. Okay, I'm just interesting. And so I was wondering if we could kind of zoom back, take a step back, and if you could tell the story of how what was before CardinalKit, now Spezi, how it started and how it's grown to what it's become today.
So it was pretty organic. Yeah, it was back in 2012 is when I first came to Stanford and started doing a lot, running these digital health studies in patients with cardiovascular disease. And, it was pretty hard. It was very expensive, took a lot of time, not only to build the applications, it was hard to find developers, dealing with the hospital IT, right? Getting through the privacy, security, audits and so on. It was a pretty arduous task. But once once I did that once, a lot of other faculty members would come to me and say, I want to build a digital health application, or I want to run a research study. Can you help me? What do I need to do? And literally after like the 10th or 50th or 20th time, somebody came to me and I had to outline everything and like take him from 0 to 1. It became really evident, like, man, we're reinventing the wheel every single time we're doing this. So there was a brilliant CS undergrad, Santiago Gutierrez, who actually, I teamed up with, and he helped me kind of develop CardinalKit, which in its earliest form, as Vishnu mentioned, it was really just a template application, leveraging existing open sourcing frameworks and iOS like ResearchKit, and the from Apple. And so that's kind of how things got going. And then really the catalyst to really develop it was that we noticed there was a need also to teach a class. So I teach 2 classes. One is called Basic Biodesign for Digital Health, where we just teach the fundamentals of innovation through the biodesign needs-based approach, using kind of a digital health lens. And then we noticed that a lot of teams would have these great ideas, but they needed support to build whatever concepts they came up with. So we came up, it's in its 5th year now, called Building for Digital Health. And so for that class, we kind of created this CardinalKit framework so that the teams would have something to start with. It's only a 10-week course, and that's how it all started. That's how CardinalKit started. And the nice thing is that every year we teach the class. We have about 5 projects that we build that are sponsored by faculty in the hospital. So the real world projects that faculty want to deploy.
Wow.
And so it's almost like a forced function to kind of force us to update the code base, crush the bugs, and, just keep up with the latest and greatest. And so that I'll stop there. That's kind of how it started. And then Vishnu joined the teaching team, obviously contributed quite a bit, not only on the teaching side, but within the framework. And then last year when Paul joined is when we realized, we noticed that a lot of the students would spend, a lot of the time starting with a CardinalKit template application, but then having to break it apart. Because they'll say, I don't need the Bluetooth connection for my use case. And so they would take some time to break that apart. So we said, why don't we just modularize it? So you only pull or use or leverage the Bluetooth connection module if you need it. And that's kind of what Paul did. And so we decided, so there wouldn't be confusion, to rename it to Spezi, the latest framework, So that brings us up to, I don't know if you guys want to add anything else. You can add another,
Yeah. I think it would be good if Paul can kind of like talk a little bit about that whole process of how he came up with the architecture and like, what kind of issues.
And also the name. I'm curious,
And there's a really, Paul actually came up with that name, and there's a really good story behind that name. So yeah, go ahead, Paul.
First of all, maybe to start with the name, Spezi sounds a bit interesting, I think, especially for an English-speaking audience. But it's actually a German name or a Bavarian name, which is like the short name for buddy, which is actually kind of nice.
Oh, yeah, that's nice.
With a framework of smaller modules, which ideally all work together as buddies to really help and facilitate a larger digital health ecosystem. And in addition to that, it's a very good, very southern German drink, which is like a mix of Coke and like an orange soda, which is not that common here in the US. I've never really seen it.
Sounds pretty good.
Pretty good drink. I can recommend.
Can I correct you, Paul?
Goes to
so orange soda. All right, I just want to correct you there. Orange soda in the U.S. apparently is not the same as it is in Europe. In the U.S., apparently it's just like 99% sugar.
Yeah.
As I tried to make Spezi at home, and it tasted completely wrong, like nothing like it was in Germany. Then I went online and I looked up recipes, and they said, no, don't use American orange soda. You have to use like sparkling lemonade. Or something like that. And that was actually much closer to the actual Spezi. So for anyone who's trying to make a drink at home.
And we can always celebrate with that drink when we're out, like when we go to Germany. It's always a good drink. It's highly recommended. And that like sort of like idea of like having multiple bodies that work together on like building a digital health application. I think really like translates this very well into like what we want to achieve with Spezi, which is I mean, if you look at larger scale systems, this was like a lot of part of my PhD as well, especially looking at distributed systems, but software systems in general, and which I assume that every listener here who has built software before might have seen that happen a lot, is that when you start building them, you start maintaining them, they grow by size. They grow into more complex systems, harder to maintain systems. And in software engineering, what you really try to do is we try to decouple specific functionalities into smaller modules, which you can use independently and you can also swap out. So a lot of the stuff that we did at the beginning when I joined the team was looking at the current CardinalKit template application and really try to identify what are the core needs there, what's the important thing that is addressed by that framework, and how can we separate these out into smaller components. And when we think about the digital health system, and especially in the context of machine learning, we have multiple stages that data goes through. So you have like a data collection process most of the time, which is in our case, patient-reported outcomes or surveys or scheduled, like anything that scheduled surveys or tasks, anything that patient needs to do on a regular basis that they can manually enter into the application. This can be like digital biomarkers, stuff that you get from like Google Health Connect or Apple HealthKit, which is like all the passively collected data that's from your smartwatch, from your smartphone. A lot of the stuff that is easy to collect and really passively collect enables you to get objective measurements from patients, as well as some other data sources, like elements where you have like patients doing workouts, some other data that can be collected from connected devices. We have connected devices that use Bluetooth connections to get more information when you actually do a test, or when you walk around, and all these different other aspects. And all these different data sources can be separated into smaller modules that try to collect the data and then as visually to really try to bring this into a standardized format. Because any data processing, any data scientist that you have will tell you that it's important to have data in a structured format, compared across different data sources, and then actually feed it into any type of algorithm. Can it be an expert system? Can it be a machine learning system? If you have some structured data and you have it pre-processed in that sense, just makes the whole workflow way easier. So this is really where the standard comes in. After we have all the different data sources in place, all the different modules in place, we have the standard representation, HL7 FHIR, OpenML, all these other components that are then used to process the data, provide users feedback about the data, which is really crucial. Like if you have a digital health solution, if it just collects all your data, it never really gives you anything back. It's like, it's a black box for a user. Yeah. It doesn't improve usability. So it's all about like presenting the data back to the user, making sure that they understand what has been collected, making sure that all the permissions that they've given to the application actually adhere to it. So we only collect data that is really needed for the study context or for the research context that we're looking at. And then really forwarding that data into data storage providers like cloud storage mechanisms, or sometimes even just a local storage. If you don't want to send something to the cloud, it's totally fine. And it depends on how your IRB or how your privacy policy is constructed in that sense. So then bring this into a context where somebody can do analysis on this, where somebody can take a close look at this. And this whole process, and we've looked at this different process from different applications, will then form the architecture of what we call Spezi. Because we still maintain CardinalKit, maybe to be fully transparent about this, it's still in existing projects. We have more than 20 projects who've used it, who are successfully building on top of that template application, and we continue to maintain this. It's like a learning from software development. You can't just shut down software and hope people move on. We'll still maintain it. But the new architecture that we have in place and all the new projects that we're onboarding, that we're collaborating with, build on this new architecture, which doesn't share any code with the previous code base that we have there, really then helps you to think about your digital health applications in these different smaller modules, in that workflow from collecting data, standardizing it, forwarding to cloud storage providers. And then this is really the topic of your talk here and your podcast, to bring this to algorithms, to machine learning algorithms, to take a look at the data, process the data, and then provide that feedback back to the user. This processing can happen on device. I mean, that's really the key. Yeah, sometimes you want to adhere to privacy, you want to do it on device, or like in a cloud system. Here at Stanford, we have an health platform, for example, to enable you all these different mechanisms of storing and processing the data, or somewhere else. So that's longer story of how to think about it.
Yeah, I mean, the basic arc of the story is literally starting with one study, having other people, identifying the need that there needs to be a easier way for people to lower the threshold activation energy to be able to deploy an app. So then the class was big. I think the class is a major function to help reinforce and support and maintain and update the framework. It still does even today. And then, I guess the last piece of the story of the arc is the modularization that we've done as an update.
The modularization, to me, it almost feels like Lego blocks. It seems like you have different module components that are like Lego blocks that are really good at, whether it's processing the data or, like you said, cloud storage. It's like they have their own unique roles, and you're building each of the different blocks for that. Is that?
That's actually the same analogy that I use when I'm trying to explain this to people. And I think one of the really cool things is that because this is an open source project and an open source ecosystem, anybody can build their own Lego block. Like, wow, you can Lego blocks for, your particular project, your particular need, your particular device. And then you can keep that for yourself, or you can, send that back to us and we can make it available for the entire community. So the idea is we're trying to create this ecosystem of modules that can support all sorts of different use cases, and everyone in the community can benefit from someone else who has built something that maybe they also need. And the idea in open source projects in general is that because there are so many people around the country and around the world using it every day for their projects, they will find bugs, they will be able to update things, and they'll be able to contribute. And so the entire project keeps growing and improving over time.
Wow. That's awesome. I was wondering, could you tell us some of your favorite applications that you've seen built?
Oh, that's a tough one.
I think we have to, we never have a favorite. We can't.
Oh yeah, sorry.
But I think one that, I think the Buddy app is pretty cool. And the reason I like this story is that it kind of highlights kind of what CardinalKit Spezi was built for. Okay, so we had this medical student. His name was Blinn. He had actually done a master's, I think, in bioengineering at Columbia, and as part of his master's thesis, he had developed kind of this bespoke sensor, like a wrist-worn device or sensor for kids with cerebral palsy. And part of the therapy or treatment for kids with cerebral palsy, they have weakness and kind of range of motion issues in their upper extremities often. And to help with that, they're supposed to do a lot of these exercises. And so he built, I don't even think he had an application. It was just this wrist-worn device. And it was great. He was able to build that one device, and that was it. It was hard to scale. And he came to Stanford. He's like, okay, I want to mass produce this device or figure out a way to scale this. How can I do it?
Was it like a monitoring device? Or?
It basically had an accelerometer in it, and it basically provided feedback to the kids as to whether the force was strong enough with the movements, things like that. It helped.
Oh, at the time that he developed this, first of all, it was like a brick. It was literally this big. And the kids could only use it in the lab, and it had to be tethered to a computer that ran MaTLAB. So, it was an amazing invention, no question about it. But the fact is that it was limited to a research lab at that point.
So he actually took my original Biodesign for Digital Health class. And in that class, I kind of learned about his passions, what he had done. So we said, Blinn, take the building course. Why don't you instead use an Apple Watch? It has accelerometers. We can get access to those accelerometers. And build an application around the therapy that you want to provide for the kids.
Wow.
And it was pretty remarkable. He got a huge team around him. They were part of the class. They were able to build I thought it was pretty remarkable. They were able to create real-time feedback on the phone. So the kids would move and you would see these lines go up and down. And with that real-time feedback, you can imagine, if your force wasn't strong enough, it would give you that immediate feedback.
Yeah.
Therapy, he had videos with instructions on which movements to, proceed from one to the next. So I don't know. that's one project I want to highlight because, again, the part I want to highlight the most is that it provided it took this project that was incredibly hard, right? He faced so many hills and challenges to scale this, and we were able to get him to a point where he could scale it. So to me, that's pretty exciting. I don't know, you guys talk about a project.
That's the coolest. I think what's coolest about that is, now that he's built this app in such a way that any Apple Watch and any iPhone can do it, right? So it's something that you go to the App Store, you download it, you install it, and then you can just start using it. So it's that bridge from something that was revolutionary but would never have made it out of the lab to something that can be used by anyone, anywhere with off-the-shelf technology.
I think that's something we really focus on is translation. And, as you'll find over time, there's so many labs that have an amazing algorithm, an amazing model, connected to, their computer, their desktop, their research facility, their research lab, translating that, scaling that, the ML ops is actually pretty challenging. But I want to focus on the projects. We'll probably end with maybe you can talk about HealthGPT or...
Yeah, that was actually how I originally heard about.
Right, but I think we should talk maybe we have time, or do we have time? Maybe Vishnu, you talk about one other project that would go to HealthGPT. Which one?
Well,
you want to see the derm? I like Golara's project. That's a really interesting one. What do you?
Yeah, that is an interesting one. So the idea is,
I would even tell a story about her being written up.
I got written up. Oh,
I'll start the story. So we had a dermatologist, I'm not going to name names. She had a dermatologist. No, she did nothing wrong. Dermatologist had a patient come from Chico to the Bay Area for eczema. She needed like allergen testing, like a patch test. I think she was charged like $48,000 for that test.
wow.
And then she somehow made it to the news and was written up. And I think this dermatologist was like determined, okay, we got to come up with a cheaper way, home-based way to be able to, offer these eczema, these allergen tests, these patch tests from home. So I'll stop there, and then Vishnu, you can. So she applied to the class. She was one of the professors that applied to the class with a project.
Exactly. So she basically, when she came to us, she said, this is a big problem because very few people in the country actually have access to the patch testing, which will, help them elucidate the actual cause of the eczema, of the dermatitis. And I think the figure she gave us was about 2% of people who should be getting this testing done actually are able to do it.
Wow.
Just because, they don't live in the vicinity of a clinic that can do this, because they have to physically adhere patches to your skin, and then you have to go in and get checked on multiple occasions. So if you live far away from a clinic that, has this facility, then you can't really get that done. So the idea was that we'd be able to ship out these kits to the patients at home, and then they could use a mobile app, which would basically walk them through the process of actually adhering it properly to their skin in the proper orientation and everything. And then be able to take photographs on a daily basis that were good enough to be analyzed, by a physician or by a machine learning algorithm, to detect whether or not the test is positive or negative, right? So what happened, as Oliver said, is that she brought this project to our class and kind of assembled a team around it. And the solution that they came up with based on Spezi was to use augmented reality and certain stripes on the patches so that the application could actually be used to help the patient line it up properly.
Oh. Mm-hmm.
And then they could also do some other things in the application with the camera to make sure that when the patients took the photo, the lighting was even, the orientation of the patches was in the correct manner so that it would be easier to see for the person reading it or get better results from the algorithm. So they were able to make a whole comprehensive application that can take them through the entire process of doing this testing at by themselves, and then transmitting the results, remotely to a dermatologist who can then read them and then get them diagnosed. And that's $40,000, as Oliver mentioned, would be the cost potentially to get that done in person. And this would be a small fraction of that, and can address the other 98% that just don't even have access to it.
Yeah. So anyway, I think that's a pretty cool project, and we were able to build. I mean, now granted, it's not production ready after the 10-week student project, but they were able to, they had an application. It could, it used the AR kit to, automatically take a picture when it wasn't the correct orientation. It was pretty amazing, I thought. And then you had the correct lighting and so on. And, had all these surveys and everything else. And the data was in the back end to be viewed. Like they had a dashboard. Which is,
and they had a dashboard for the physicians to be able to view that.
So that's pretty incredible in 10 weeks. And most of the students, no iOS, experience. No,
that's odd. Wow.
All right.
None of the students had ever made a mobile application for digital health. There were a few in the class who had built a mobile application before, but zero for digital health. And so it's amazing that in 10 weeks, they actually are not only able to build something, but something that can go on to actually be used in real clinical care and research.
You guys are like your own incubator.
We just facilitate the things. All right, talk about, which was kind of more of a research project. This didn't come from, the HealthGPT wasn't a something that came from faculty sponsored or student, anything like that. We could talk about that a little bit.
I think that's another very good example, first of all, how Spezi just enables you to prototype these types of applications and build these types of applications faster. And the thing where we are also really passionate about in the sense of like trying out new avenues of exploring health data, because a lot of the time, maybe to give you some background or some context in that sense, like as a medical professional, you have a pretty good idea of how to look at data and how to assess the data. And you have tools like machine learning models in a clinical context that help you to understand data that you have in front of you, or you have your expert knowledge to make it available to you. But I think on a day-to-day life, for those people out there who might not possess that knowledge, it's sometimes hard to take a look at your health records or the information that you might even get out of a hospital system through these FHIR APIs that Vishnu talked about at the very beginning of the podcast, or even just the data that's stored on your phone. And the idea was really, and we had a really talented student, Varun, who really built the first prototype there, was to assess the capabilities. And I know that this is a buzzword right now around large language models, but I think this is we see a good application for these models, for these conversational interactions, especially on health data, to help people to understand their health data, to ask follow-up questions, and to really make it as accessible as possible to everybody. And the idea around HealthGPT and another application that we've built, which we call LLM FHIR, which is the FHIR standard that we've talked about, really tries to enable people to access their health data and to make it explainable. So HealthGPT accesses the data that's stored on your phone through your step count, how much you've slept last night, all the different activity that's stored in there, provides you like a contextual, like conversational interface to query that data and to ask follow-up questions. What does it mean for my health? Like, how can I improve my sleep? How can you see these different elements? And using those interactions with a large language model, using pre-prompting and adding additional prompts to feed that health data to the large language model, we can really assess that interaction. And I think even more fascinating and even more like bringing this accessibility aspect into the picture. We took a second look at the data that you can get out of your healthcare provider, like from these FHIR APIs that Vishnu talked about. We built an application that we call LLM FHIR, which allows you to pull these health records through the health app.
Is it called LLM on fire or
LLM on FHIR? So
yeah.
language model is really
fun. That's funny.
In the FHIR community, because FHIR is pronounced fire. There's all these ones about things being on fire. And like, so I was at a conference where the AMIA conference last year where like, a lot of the attendees are FHIR experts or interested in FHIR. And someone pulled the fire alarm, and you should have seen that with her. All the puns.
That's funny. The fire alarm.
You can't believe we have
Sorry, in that direction.
it on FHIR, which allows you to get health data to a FHIR format. We have research.
Kit on.
So we're really like on fire with these tools. Yeah, I'm gonna stop there. But really, like you have these health records, which are most of the time provided in a machine readable format, hard to interpret, contain medical information that might not be accessible for somebody who might not have that education. And by really trying to list these things down and beyond like a graphical representation, really ask you to allow follow-up questions, use the context, provide that context to a large language model. What we think is really powerful, what we really want to investigate further with these research projects and want to spark a conversation around there is like, how can we use these machine learning tools to make this data as accessible as possible? Maybe even for people who might not have English as their first language, it might be better to translate stuff into Spanish. This is things that we've explored and want to look into. And all these different capabilities are really interesting. And by having this on your mobile phone, which everybody has like a smartphone, most people have a smartphone in their pocket. This really makes understanding your health data and really access to your health data, really accessible to everybody, which is really interesting project and what we wanted to discuss with these different elements. Of course, and we should talk about this later on, also concerning privacy, how to interact with these models, how to make sure that you run these things on device and all these different other aspects. But
before you get into the privacy, I want you to continue. This is really good. I think just to highlight, we're always focused on the end user who's not necessarily a physician or clinical specialist. It's more like how can I as a consumer better digest, better understand that all the information. It's hard, right? Even honest, yes, Apple has great user interfaces for all this, data that's on the phone. But at the same time, let's say you want to compare your activity data to your sleep data. I think an LLM can do that much better, or has a greater capacity than me trying to go back and forth, just what my sleep pattern's done, or how my sleep pattern maybe is affected by my activity, or vice versa. Or is it related or not? As an example, or more importantly, let's say I get a note, right? A clinic end of and a summary of a visit summary note, and there are a lot of these there are medical terms in there that I just don't understand. I think it provides a really interesting way for a health consumer to better understand and try to, digest all that information and try to make sense of it. So that's what we're really excited about. And as Paul said, even if it's just a simple translation to Spanish. I mean, if you're going to Silicon Valley, you better, I don't know how your Spanish is, but you got to know Spanish, because that's number one thing is like literally literacy, English literacy and is a challenge. And so anyway, there are a lot of opportunities. I don't know if you wanted to add anything, Vishnu, to that, but I think we're very, very, when we released the HealthGPT, probably the number one concern and question and comment by far, I would say 80% or more, was all about privacy. Like, are you crazy? I'm never going to send my health data to health OpenAI. Are you nuts? You guys are insane. And even though it's just a research project. So I think the concerns are real and fair, about privacy. And so I think you can talk about what our next kind of the work we're doing this summer. I don't know.
How did you respond to those people who would?
Well, I mean, I didn't told David. It's not a fun thing to do, but sometimes you just have to.
Would you say fighting the trolls? Yeah. Oh man, it is. I feel like the field is on fire right now.
I know, on fire. No, but seriously, those are very legitimate concerns around privacy, and I think, like, we put this project out there just to, we started this research project just to see what's possible with these models, right? And, models in the cloud are the largest and most capable models. And that gave us kind of like a benchmark for like, what can we actually do? And now we're trying to figure out ways to make it more privacy preserving. So one of the things, and I'll defer to Paul to kind of go over some of the stuff we're going to be doing this summer, but I think one of the things we're looking into, first of all, when we created HealthGPT, HealthGPT does not send personally identifiable data to the cloud at all. Actually, it sends aggregated statistics about your activity and sleep and things like that. And then we went one step further to think about how we might, narrow down what needs to be sent based on the question that's being asked. So the idea here is that, when you prompt the LLM, you can actually kind of create a chain or a function. OpenAI has functions, so you can kind of say like, hey, this is the question that the user is asking. What pieces of information would help you answer this question? And then you can reach into the database on the phone and HealthKit or Health Connect and just pull out those pieces of information and not necessarily send lots of stuff that you don't need to. So I think that's something that we worked on too, which is really another way to kind of protect privacy. But I think the most interesting piece of this is being able to dive into this treasure trove of data and surface the pieces that are relevant to be able to answer a user's question. I think that's a big deal because there's so much data sitting on phones, sitting in the chart, on the clinician side, or in your MyChart patient portal app, which you really would never be able to go through all of that and understand all of that on your own. And with a model like this, you have the opportunity to ask detailed questions, surface data and trends and correlations that you may not have realized exist, right? And that could be helpful for your own, self-knowledge, your disease management, for your clinician to understand why things are going on, because when you're in a clinic visit, I'll keep it short, but like when you're in a clinic visit, as a clinician, I have 10, 15 minutes to talk to somebody. You're going to see that, David, when you get, start your residency. You have very little time. And in the middle of that time, you have to write a note. You have to click all these check boxes. You've got messages coming in. You've got, someone coming in saying like the next patient is upset because you're running late. So in the middle of that, trying to make sure that you get all the information you need from the history from the patient in order to make a correct diagnosis is super hard, especially when like they may not remember everything that happened, yeah. But their phone probably does know what happened.
Yeah, it's interesting. I would also, I think really important on the privacy part, I mean, the way we handled a lot of the trolls, ironically, literally a week before we released, I believe OpenAI said, okay, we're willing to sign a business associate agreement, a BAA. I don't know if you've heard of that before.
Oh, I think I remember their announcement. Yep.
Exactly. So if we were, in a covered entity, we wanted them to use their service and such, we could sign a BAA with them, which is HIPAA compliant or would be HIPAA compliant. And then also they said you can opt out of sharing, your data. They do hold on to data for 30 days in case there's some malicious activity, but then they would not use it to train their algorithm. So, these are kind of soft things you could do to protect yourself. But I think the real money or the holy grail would be what Paul is going to be working on this summer.
So it's, I think all these privacy and security concerns are very valid. And I think especially if it comes down to your health data, I mean, that's the most personal data that you can have. And I think we should really be careful of how we interact with that data. And one mechanism that we've seen in computer science for quite a while now is like trying to move computations and elements more to the edge of networks, to where the actual devices are, where the actual data is located at. And in that case, that is really the mobile phone, because you already have the health data on your mobile phone, because you've downloaded it from your healthcare provider, you have obtained it through these FHIR APIs. And the really holy grail, as I would have said in a sense, is really trying to process that data locally. Is it easy to do? Definitely not. Can your phone turn into like a space heater if you run like a local language model locally? We've tried, but at least things are progressing step by step, and things that have not a year ago will become possible in the next few months and will be more accessible in the next year. So what we're really trying to investigate is, like, first of all, how can we try to run these models locally? And we've not only done this for this project, but for other projects, because ideally you try to process the data as close to where the data is actually being produced to really reduce latency, first of all, and second of all, to really help privacy and security aspects, because any data that you don't really share, don't really send anywhere is better to treat it.
I mean, there's some LLMs that run locally now too, right? Like llama or alpaca.
Exactly.
I get all the animals mixed up. So
exactly. I mean, it's a challenge to run it locally on a machine and then running it locally on your phone, which is what people really have in their pocket. So there are multiple different steps that need to be taken. But yes, exactly. This is where it's going. And this is really how we can address all these concerns and really build a solution that we can not only have in our research lab and share as an open source project and like ask people to enter their own open API token to make sure that they are really in control of all the data they're sending back and forth. And we don't really see any data. Once again, like that was never part of the project in itself. But even that interaction, sending into their own open API account to making sure that the connection is there, might not be needed if we can already process on this side. This is really where I think the whole machine learning area and expertise is really going to move more and more towards try to build local, maybe even specialized models.
Yeah, that actually takes me to my one of our closing questions.
Okay.
What I almost in talking with it, I almost have a feeling of where you're going with it, how you're going to answer. The question is, what do you think the future of AI in medicine will look like in 10 to 20 years? And from what I've heard from you, it almost seems like everyone is going to have their own unique Spezi or their own buddy, which is kind of their their own health GPT on their phone that has access to their records, and it has like its own LLM, like a local LLM or something in the phone, and then you can just kind of interface with your data. It's kept private because it's all on your end. I'm sorry if I'm like putting an answer into your time.
You nailed it.
You
nailed it.
Marketing.
So, of course, of course,
no, 100%. You absolutely nailed it, and it'll kind of be more aligned with you, right? Everyone's a little different in terms of how you want your answer. Do you want your answer in Spanish? Do you want it in English? As a very simple thing, your level of understanding. Are you whatever that may be. There's so many layers to that, but I think there'll be multiple AIs, but more local, as you said.
Yeah, I think the personalization, local processing, and also like specific, trying to address specific needs. I mean, in the end, is it gonna be one large language model that's gonna solve everything? Definitely not. Definitely not. It's not the right tool for everything. It's probably not even the best tool for all the different things that we're currently using it for within research and even within our projects. But it's a very good starting point to explore in this area and to like really think of you as the owner of your health data, and then giving you the capability to understand, to process, and really drive it forward is I think where a lot of the work in machine learning in that area is going to focus on. And there's going to be lots of innovations happening around that. And it's going to be really interesting. But I think this is really where we want to focus on, and where we see adding that context, providing these follow-up questions, like trying to analyze all the data that's currently being processed, that can help you to make early diagnosis and to help you to figure out if you're actually recovering after a procedure or if you need any follow-up visits. This is really, I think, where the healthcare space and these local process models and elements can really make a huge difference.
I think Vishnu needs to talk about a project. I think also the future will be hybrid. It's not only LLMs. I think expert systems have their place, and they're not going to be gone. And I think Vishnu has a great example with a project he's working on called HeartX, where it doesn't make sense to use an LLM. It makes more sense because you want, when you have a system where that's making clinical decisions, like picking the dose of medication, choosing the next medication in a blood pressure management regimen. Do you want an LLM that's going to be a kind of or do you want something that 100% follows the guidelines, right? Mm-hmm. So I think, and Paul as well, and Vishnu, that it's going to be kind of a hybrid system, that there'll be times when you'll be like, okay, I'm going to go ask my expert, system. I don't know, Vishnu, if you want to talk about the example of your HeartX or the blood pressure management.
Yeah, I mean, very briefly, I think the concept there is that we can manage hypertension remotely using a semi-automated guideline-based expert system. And essentially the idea is that patients have Bluetooth blood pressure cuffs at home. They're going to be checking their blood pressure, ideally like on a daily basis. That data will be uploaded through a mobile app to Epic. And from Epic, we have a connection to an algorithm that we've built. And the algorithm was built by a team of experts who've read through the guidelines and put together a carefully crafted algorithm that actually makes medication recommendations based on a combination of blood pressure and other data from the chart, like their lab values, for example, because certain medications are, affected by certain labs and vice versa, and also by allergies they might have, symptoms they might have, things like that. And so the system is carefully built using, up-to-date guidelines to be able to take all that information and then synthesize recommendations for clinicians to review and act upon. And this happens constantly in the background. So normally, when we treat hypertension or any chronic condition, what happens in most cases is that a person comes in, we make an adjustment, they go home, they come back in weeks, possibly even months later, we check again, we make an adjustment, and what happens in between, we don't really have an opportunity to intervene, right? But here, by using this system that is constantly monitoring and constantly, adjusting, we can get better control of the condition quicker. And what's really helpful about the way the algorithm works is that it's not a black box. We know exactly how it was built. And when it gives a recommendation, it will tell the doctor exactly why it recommended that. That, for example, I saw this data point, I saw this lab value, I saw this allergy, and I'm working off of this guideline. I'm on this step in this guideline, and that's why I'm recommending this. So it's completely explainable, which I think is super important in healthcare, because as a doctor myself, I am not going to go to ChatGPT and just throw a bunch of data into it and have it tell me what to do with the medication and just do it. I need to know where it came up with that from, because this is an issue of patient safety.
That's great. I like the hybrid idea where it's, sometimes use an LLM, sometimes have more professional kind of baked in guidelines. I did want to close with a bit more of a personal question, just to, I kind of like to end interviews on just with like kind of more about you question. I'm curious to the three of you, what brings you joy? Feel free to answer that however you'd like. And yeah, in any order you like to.
Yeah, no, I guess, a lot of things. I think, for me, seeing these, like the translation gives me the greatest joy. Again, there's so much excitement about the potential and the opportunity, but the actual implementation and translation is so hard. I've worked on so many digital health projects, for years, and, there are many headwinds in healthcare when it comes to digital health in particular, because, we tend to be focused on prevention, early detection, personalized type care, which I think our current health system is not always aligned with what the, what the incentives, where the incentives are. So for me, when I see these applications actually built and translated and implemented, that's what brings me joy in this sphere. Many other yeah, in this context.
I would say, like, beyond this conversation, which was a joy to have, I would say definitely, I think, like, having the ability to take one's knowledge, like one's expertise, in my sense, of the computer science knowledge, and apply to something that's meaningful, that actually makes a difference. And I think this is where we are in the healthcare domain, where, especially on digital health, we really have a change to have scalable solutions that can impact a lot of people, and bringing this expertise together, working with people like Oliver, like Vishnu, really, and collaborating on these different elements to make a difference there. It's a really joyful experience, I would say.
Vishnu?
I can add to that. Those are really good answers. Yeah, I think what brings me the most joy is like seeing something that I built in someone's hands doing something good for them, right? So like I've built a lot of digital health apps, and I've been working with Oliver and Paul on all these different projects. And what really is awesome is when you see that actually deployed in a real clinical environment, and you see a patient actually benefit from it and come back and say like, oh, wow, like this is awesome. I love this app, or it's really changed the course of my treatment, or whatever it happens to be. It's that part of it is what really matters. And building these apps and getting them out there is such a frustrating process sometimes. So oops, to jump through, there's so many issues. There's so many days where you think it's just not going to launch for one reason or another. There's times when you're like, it's almost ready, and then something breaks. So all of that is worth it when it's finally out there and you actually get results back, and you get people coming in and saying, I love your app. This is awesome. It's completely changed the way that I'm managing my condition, or whatever it is like that. Like there's really no feeling better than that, honestly, in digital health.
Wow, I really want to ask one last extra question. And the question is, I feel like you've probably seen so many teams try and build these apps. I'm curious if there's like a secret sauce, or there's something that, like, is there a common denominator in successful teams like that are able to build something?
Don't give up. Number one. Use Spezi. No, seriously. I don't know. I don't want to name the names, but there are a lot of, having a developer team or people that have healthcare expertise is worth its weight in gold. I know we've seen so many teams go with like, oh, I have a very inexpensive dev team in Africa or whatever, or we're going to use this professional dev team. They've never done healthcare, but they're professional. Disaster. Absolute disaster. So, you talk to the Epic team and they're like, you got to do this in FHIR, this FHIR format. They're like, what's FHIR? You know, I mean, there's just, I don't know.
That's true. That's great. Yeah.
I'll let you guys add to that.
I think the bringing, I think we're a very good example of a team where you have the intersection between computer science and healthcare combined into a team where you can really talk about that expertise and really learn from that. And I think from my background, there's like having a PhD in software engineering, a key part of like building systems that actually succeed and actually get into patients' hand is really trying to understand the need and the problem that you're trying to address, really work in the application domain, observe people in that domain, and really try to understand what you're actually trying to do, and then to translate this into software. Because so often you just build software which is completely
I have to jump in. I totally agree. I think so many people focus on building the perfect application with all the features. No. No, one of the things is pick one killer feature and focus on that one feature and get it out there and get feedback. I highly recommend that. So many people are like, no, it has to have everything baked in. No, you're going to waste time, money, energy, experience. That goes to what Paul is saying, just to really focus on what are you trying to solve?
Yes.
And what is that, that kind of Trojan horse or whatever feature that's going to get you where you need to be. I don't know, Vishnu, you have so much experience. I should let you talk.
I think you and Paul basically covered most of it. I think what we've seen, like we've worked with 5 new teams at least every year in our class. So we kind of have an idea of like what works and what doesn't, just like by observing how students work and how they interplay and all of that. And I think the teams that work together the best are the ones that have diverse skill sets. So you have people who can code, you have people who can design, you have people who understand like the use case really well. You have people who have sometimes, personal experience with the problem that you're trying to solve. So they've been in the shoes of the patient who actually is going to end up using this product. And that's really valuable experience. Like even if you don't have someone on the team like that, it's really valuable for the developers of the product to be able to at least connect with people who have dealt with those issues that you're trying to solve, right? And one of the things that happens a lot in our class is that we actually, the faculty that are working with the students will actually take the students to, the clinic or, introduce them to some patients who'll be willing to talk to them, and they'll show them a prototype, and then they'll like sit there with the patient while they work through the prototype, and they learn an insane amount from them. Because if it's just the 3 of us sitting in a room thinking about what might work for somebody, we might think we have the perfect thing built out. And this has happened to me so many times. I'm like, I know this is the easy problem to solve. And we said, I don't even need to do user testing, no feedback. This is done. Well, let's build it out this weekend and ship it. And then we ship it and find out that no one wants to use it because we overlooked something very, very crucial about their experience and like the way they experience their condition, right? So that's really, really crucial, I think.
Great question. That was a good question.
This was such an enlightening interview. Thank you all so much. And to our listeners, please check out Spezi, formerly known as CardinalKit. It seems like it seems like it would really be worth your while, especially if you're interested in building something. Oh yeah.
Have a Spezi. It's hard to find. There's a place in Brooklyn.
Yeah, it's funny. That's funny. Thank you so much, Oliver, Vishnu, and Paul.
Thank you so much for having us, David.
Thank you so much. It was a pleasure.
All right. Let's stay in touch.